Hi everyone, and welcome back to Building Your Own Video on Demand service. I'm Dr. Pete, and today I'm joined by Tom. Welcome.
Hi Pete, and hi everyone. My name is Tom McMeekin. I'm a data and analytics specialist.
And today we're going to be talking about building your own smart player. This is episode 5 in the series. So Tom, you want to walk us through exactly what it entails to build a smart client that actually sends interesting telemetry down the back of an infrastructure that we've got here on a whiteboard. Do you want to walk us through that?
Yeah, absolutely. So Pete, if you think about all the different insights that can be gleaned from a smart player, think about all those actions that are happening down on the edge from your clients who are consuming those video assets. You know, things that really drive insights around what video that customer has just had. What is that experience that customer has just experienced by watching that video? Did they watch all that video all the way through, or did they abandon it halfway through? That's
quite daunting, by the way. I mean, if you've got 1,000 or 1 million users using the actual service, that's a lot of data you're trying to ingest in real time.
Yeah, absolutely, absolutely. And that's where a service like Amazon Kinesis data stream can really help remove that heavy lifting away from ingesting different types of data sets that might be occurring at different volumes and velocity into and enabling you to start to get some insights from.
So what exactly will Kinesis actually do for me here when I've got millions of devices trying to send real-time data down the pipes here?
Absolutely. So if you think about these different clients here, so they're generating multiple different events that are occurring, as I mentioned, based on those activities. Now, Kinesis data streams enables you to ingest those data sets across a highly available and scalable mechanism into AWS. Now from there, we're starting to look at what can you do with that data as you've ingested it in.
Right.
And this is where Amazon Kinesis Analytics can help provide some analysis on those data.
So what does that actually do? Because obviously this data is still in flight. What's actually happening?
Yeah, so what's actually happening is this data is being ingested in this pipeline, and what we can do is we can add a Kinesis Analytics capability or an analytics application onto that data stream that can enable you to effectively write standard SQL statements on that data stream.
So if I'm a DBA, I could actually write standard queries against an in-flight data stream.
So standard query across that in-flight data stream. So
awesome.
think of all the things you could potentially glean from that. Mm-hmm. You can effectively, from a windowing standpoint or a time series standpoint, understand exactly what's happening with that user experience across that particular time that you're focused on.
And can I look for maybe some unusual behavior that my clients might be actually experiencing?
Yeah, so that's one of the awesome things about analytics. So Kinesis Analytics enables you to effectively plug in different insight mechanisms that can look for anomaly events, for example. If you think about what an anomaly event might be from a video on demand platform, these are things like bit rates that your clients are actually getting from the video assets they're streaming. And maybe you're wanting to measure that different types of experience based on that bit rate. So if you think about from a network congestion standpoint, and if your clients are in a particular region who are all of a sudden shifting bit rates down to a lower quality, you might want to get insights from that and be alerted to that and be able to understand what's actually happening and impacting that customer experience.
Right. So Tom, that gives us an option to do two things. One is to do real-time analytics and one to do some later sort of analytics done by data scientists. Can we just focus a little bit more on the real-time aspects?
Yeah, absolutely, Pete. So once we've got our data that's streaming into Kinesis Analytics and we're getting some insights and real-time aspects there, one of the things that we see customers look to want to do is to have a real-time feedback into your application stack. Now, this real-time feedback can go into aspects from Kinesis data streams. So think of a SQL statement that's being generated and applied across the data stream that's coming in from the platform, and we feed that back into another Kinesis stream. Now, the reason why we do that is effectively we're starting to fan that focused data set into another stream that's specific to the application that we're wanting to feed back to.
And tell us about the Lambda here. This is the app logic that you're going to now apply to this stream?
Yeah, that's right. So AWS Lambda we're utilizing here to apply some logic to effectively collect the messages that are placed back onto the Kinesis data stream, and then apply some and hand off into Amazon Dynamodb, which is our user content store and our user profile aspects to provide that real-time feedback that feeds into the front-ending platform back to our user base.
Right, in the previous episodes you guys might have seen us talking about user profile, so now we can actually collect all the actual user behavior and attach it to a particular user profile.
That's right.
Very cool, very cool. So what about the other side of the equation, Tom? What else could we do on this side? I'm seeing Firehose popping up. This data stream doesn't just stop, it keeps on flowing. What can we do with what's in the pipe being pushed elsewhere perhaps?
Yeah, so that's the actionable insights piece. So we want to also explore from a visualization standpoint. So how do you actually feel that pulse of what your users are, or see that pulse, what your users are actually seeing? So this is where Amazon Kinesis Data Firehose plays a significant role here, because it effectively is that managed delivery capability that enables you to stream the data, or take the data that's coming in from your Amazon Kinesis Analytics stream, and then enabling us to choose where we want to deliver that data set to. Now, Amazon Kinesis Data Firehose has the ability to deliver into multiple different services. So if you go into the console, you can click and choose which services you want to deliver to. So it might be a data warehouse using Amazon Redshift, or it might even be Elasticsearch. So Amazon Elasticsearch is a great spot to enable you to start to build up some real-time visualizations. Now, if you're leveraging Amazon Elasticsearch alongside the Kibana dashboarding capability, we can start to see those dashboard metrics in real time.
That becomes really fascinating, because if you can imagine getting all of this telemetry coming from the actual smart players all the way through into Elasticsearch, there's the ability to actually do faceting for searches when it comes to Elasticsearch. What are some of the benefits of perhaps using faceting, trying to better understand and group metrics together?
Yeah, so if you think about the users that will be interacting and consuming the video content, they'll be coming from different regions, they'll be using different devices, they'll also be consuming different bit rates of the content. So helping you slice and dice that information and get that visualization piece feeds into you to visualize and also build up some actual insights based on that.
Great. And then look, we often talk about building dashboards that reflect the data. So I guess it makes a lot of sense to start thinking about what kind of telemetry we're pushing and what we actually want to visualize. And if you don't actually have that data attribute, you definitely want to go back and maybe push it back into the smart client.
That's right.
That's cool. So that's great for real-time side of things. Let's talk about the other aspect of Redshift and how else we can actually enable our data scientists to get more value out of this data that we're actually collecting.
Yeah, so that's an important point, because it's really one, getting real-time aspects, but how do you actually go deeper into that data and actually unpick and start to learn who your customer is and what they're doing with the video content? And Amazon Redshift, which is our petabyte scale data warehousing platform, is a great source to enable you to start to glean those insights. And getting those insights can be done through a couple of different mechanisms. Right. And here we're going to utilize Amazon QuickSight to do some visualization pieces.
So how is QuickSight different from Kibana, perhaps, that we might have been using inside Elasticsearch?
Yeah, so if you think about Kibana's great for analyzing time series data sets, whereas Amazon Redshift and QuickSight can help from more of a batch processing capability and helping you to understand your data sets in a little bit more from a business analytics standpoint.
Great. Awesome. All right, so what else can we do? So we have Firehose feeding Redshift and Elasticsearch. What about our trusty S3?
Yeah, so I love S3. It's one of those undervalued, underrated, potentially one of those services.
It's my favorite.
It is. It's so simple and super low cost, but highly effective when we look at a real-time streaming and data platform.
It's a great place for building data lakes.
Absolutely. The reason, and a couple of reasons for that, is it offers a super durable service, so it's persisted across multiple availability zones, super low cost, and there's lots of different life cycling mechanisms that you can have in place around that. And also, what's also awesome about Amazon S3 is it has direct integration with Amazon Kinesis Data Firehose. Fantastic. So as this data is flowing through all the way from the top of your client users, you're effectively persisting your data for long-term usage into Amazon S3.
Fantastic. So once it's in my data lake in S3, what else can I do with this data? What other insights or processing can I actually apply to it to get more value out of it?
Yeah, so Amazon S3, you would effectively utilize that for that long-term vision of the data. So you might have your hot data that's being stored and reported on from an Amazon Redshift standpoint that might roll back to 1 or 2 years of data. But if you think about the long tail of the data that you're generating in your platform, S3 has those integration capabilities into other different processing platforms. Now, a processing engine like Amazon Athena, which can effectively apply SQL statements and query data directly on Amazon S3.
So Tom, what's the main difference between Athena and Redshift?
The main difference, Pete, is Athena is serverless, whereas Redshift you're looking at from a cluster standpoint, so you have to think about what the different node sizes are within your Redshift cluster and the number of nodes that you want as part of that cluster.
Okay, so you got to manage your own performance metrics.
That's right.
So being serverless, how will that help?
So Athena simplifies it and allows you to effectively just focus on what is the query that you want to run against your data sets. So if we look at Athena here, Athena has direct integration with S3. So enabling you to define your standard ASCII SQL statement and run that directly onto Amazon S3 in a pay-per-query type of model.
Excellent. So that means I can get my own schema definition, map it to my data in S3, my data lake, and then run queries against it and pay for on a per query basis?
That's right, that's right. So effectively you're defining your schema in a Hive-compatible schema format, and then you run your query, your standard SQL query.
Yeah, look, so in terms of actually having Athena available to me, can I actually treat it just the way I would treat perhaps Redshift? Can I do other reporting of Athena, perhaps?
Yeah, so Athena by nature has native JDBC support. So enabling you to effectively take a BI tool, maybe like Amazon QuickSight, to enable you to start to get some visualization of that tool sets. And if you think about the different personas that might be looking at this data set, so you've got your business analysts who are doing some visualization capabilities, maybe using Redshift or Amazon Athena, but also your data scientists too. So looking to build some recommendation aspects and machine learning capabilities, and they'd be also looking to access that data and really interested in those data sets that are on Amazon S3. And this is where Athena can also help by enabling them to effectively run pointed queries on their data sets.
So Tom, in summary, can you take us through the three perhaps main things that we should think about when we are building our smart player and want to do some telemetry analysis on the back of it?
Yeah, so if you think about the different data sets that your clients are generating, that's gold for you to build up that smart player activity. So services like Amazon Kinesis and this family as part of Amazon Kinesis, where data streams provides a highly available and scalable mechanism to bring your data ingested into the AWS platform. And then from there, it's about analyzing in real time and being able to respond to it using Amazon Kinesis Analytics, respond in real time from an actual insight standpoint. And then as you're further ingesting the data and delivering it to the various different services, how do you go about looking at it from a dashboarding standpoint? And this is where Amazon Elasticsearch provides that real-time visualization of your player and really giving you that smart insights into your player. And then further bolstering out your player capabilities and making your player even smarter, then how do you go about going deeper into that data? And services that we looked at also from Amazon Redshift and visualization capabilities with Amazon QuickSight. And then also S3, effectively providing that landing zone for that data and getting those further insights to your data sets. So today we've looked at, I guess, a broad range from a pipelining standpoint. And yeah, it's really an exciting platform.
Tom, thank you so much for showing us how to build a smart player and looking us through the actual associated backend architecture. Thanks everyone for tuning in. This has been episode 5 of How to Build Your Own Video on Demand Platform. Stay tuned. We have episode 6 coming up, and we're going to show you how to take this to a global audience. Hi everyone, and welcome back to the Video on Demand Build Your Own Platform series. I'm Dr. Pete, and with me I have Sean.
Hey, I'm Sean Ray from AWS.
And for the next episode here, we're going to be talking about taking a video on demand platform and turning it into a globally available platform. Sean, did you want to walk us through some of the things we're considering if we are going to go global? Because we have been quite successful being in region. Now let's go across the whole planet.
Yeah, absolutely. So, when we get multiple users, when we get high scale up, we might need to think about going global. Things like availability, reliability. And so what we've really drawn out on the board here is a multi-region setup that we would see in common customers of scale.
So we got the dotted lines for each of the regions. So we're going multi-region. Why haven't we got any dots around the 3 icons up here?
Yeah, that's a really good point, Pete. So Rope 53 is our DNS service. It's globally available. It sits in over 100 POPs around the world. And it provides DNS services for anything external, so www.domains. We also have Lambda and CloudFront sitting out here. Now, Lambda is actually an in-region service.
Generally, right? Yeah.
Yeah, and you would have seen that in the other episodes. What we're actually talking about here is Lambda as part of CloudFront. So we can basically use Lambda inside CloudFront as a worker to do different things for us on the edge before we ever have to come down to the region.
Yeah, so we call it Lambda at the edge. So what can you do with Lambda when it's sitting inside CloudFront?
Yeah, so there's a few things that people commonly do. So one would be to resize thumbnail images based on the viewer device. So perhaps you might have an iPhone or an Android and they have different screen sizes. And so you would try and do that so that you don't have to go all the way back to the region. The other thing that you might do in there is some kind of geo-blocking. You might have specific rules around content that you don't want to serve out in certain countries, and people use Lambda at the edge to basically do that.
That's great having these out across the 100 plus different points of presence. How about going and building into within a particular region? How would we wire up each of these regions that we've drawn out here with Route 53?
Yeah, absolutely. So within Route 53, we can actually build DNS names. And on top of that, we can use geo-based latency routing. And what that will do is it will choose the closest region to your user. Based on, basically, we use a combination of kind of internet weather forecasting. You know, is the internet congested in this particular part of the world? How close to you are it? You know, those types of different things. And then we can actually build subdomains for different services. And specifically with API Gateway that we have at the top of the picture here, it can actually do what we call local APIs, meaning that each region has its own DNS entry point. So if you use geo-based latency, it will actually choose the region that is best for your user and hit that API.
Awesome.
Locally.
So that could be in Europe, so EU, this could be in APAC, and depending where I'm coming through on my public IP address, whether I'm in Europe or in the other parts of the world, I will be routed to the closest, most performant endpoint, if I heard you right.
Yeah, that's right. We can also take that further. So Route 53 has health checking in, and it will actually check the different regional endpoints and see that if they're still up and working or if they're serving errors. And so you'll always get routed to a healthy endpoint as well, which is very useful if there's any kind of service disruption or something going on across the internet.
That's great, Sean. How do we go about actually wiring up all of these into each of our different regions? So assuming we're running in Europe or perhaps in APAC here, how do we actually connect Route 53 and Cloudflare and all this Lambda stuff to each of the different regions?
Yeah, sure. So we'd use the same mechanism we're using for our front-facing domain, right? So our WW or whatever the players are hitting, and we would build a regional endpoint. So an APAC one, a European one, a North American one, and down to the granularity that you need depending on how many regions that you want to move into. And these C names would actually map to the local endpoints. So even though your players are only ever aware of one, in the back end, we would actually be using that geo-based latency routing and the local APIs here to actually serve you that content based on which is the best region for you.
Fantastic. So in that case, so I'm assuming I'm in APAC and I hit this region, so I hit the API gateway. Walk me through the sequence of the actual, compute execution. What are the actual execution paths the code would be taking?
Yeah, so once we've resolved the DNS, you'll get routed to an API gateway. In here, you'll have your different things, dash search, dash recommendation, dash create user, login, these types of functions. And depending on that service, we talked through in different episodes today around either using Lambda to provide that business logic, or maybe a fleet of EC2 in the case of something like licensing. And these are actually regionally bound, as in we don't expect you to run compute that is talking to services outside of other regions. One from a reliability point of view, you might not know whether that region is there, and also it introduces a lot of latency as you try and round trip. So these things would actually be contained specifically just inside the region. They would run the business logic, they would hit their own local data stores, and then they would return it back up to the user.
Okay, so let's just focus a little bit more on the traditional compute, EC2. So if I was to say, start off in this region in APAC before going to Europe, I'd build my virtual machines, my Amazon machine images. How hard are these to actually move across regions?
So as long as you're in the same account, you can actually move them across regions. You'll need to have a different identifier per region for each of your AMIs, but you can publish them out individually. So there might be some regions you do not want people to actually load up into, and you can also block that as well.
So that would be transferring the image from, say, from this region to the other region, and I would be able to launch this EC2 same as that one?
Yeah, and if we are going multi-region here, it's important that we talk about automation. It would be a very kind of sane choice if you're going to do multi-regions to use things like CloudFormation, use some kind of tooling that actually let you build this out with infrastructure as code. Because you don't want to be manually building different regions, you don't want to have them misconfigured. And so we expect here where you're doing that and you are copying your AMAs across, that then something is actually then orchestrating them so that you have the same version. If you release a new version here, that version goes over to Europe after you're done in APAC.
Absolutely. So that's great for code. What about data? And we often talk about data has gravity. So for example, over here, if I'm using RDS, my relational database as a service, how do I make sure that my data perhaps is in sync with the other RDS in another remote region?
Yeah, so with RDS, and specifically MySQL engine, we allow you to put a replica in another region. So this would be read-only, but it would allow you to have that user data in another region. So in the case of a disaster, you could have that read replica, it could become master, and you could build out from there.
So So it can promote basically
Yeah, that's
on
right.
a particular trigger.
So it will promote on particular trigger. It's obviously asynchronous because it is going across region. So you will have a little bit of latency, but it's quite small generally.
Cool. So, okay, another interesting one is Dynamodb because that's got a slightly different behavior. Recently, we made some changes to Dynamodb to allow more flexibility around being global. Can you tell us a little bit more about how Dynamodb actually copes with being multi-region?
Yeah, sure. So you can actually specify tables inside DynamoDB that get replicated globally.
Awesome.
And so that was a really cool feature that we've been asked about for a while. If you think about something like the gaming industry, they wanted to do a global high leaderboard across the entire globe and who's number one. And that was super hard to do before because you had to move all that data between all the different countries. So global tables allows you to do that. And in the case of here, in the other episodes, we've talked about building media asset management here, user profiles, and that means that we can replicate either all that data or subsets of that data based on legislation and data sovereignty into other regions.
Yes, with GDPR just becoming available in Europe, that has certainly implications about which data you should and shouldn't be moving, off to remote regions. And AWS is compliant, which is awesome. So in this scenario, if we are in APAC and in Europe under GDPR, so if we have a user login, for example, and my specific data, how much of that would and should I move?
Yeah, so it's a good question. Each of the regions actually have different regulations. With GDPR, you need to keep your European data in a data sovereign nation in Europe. And so we would actually have the user profile, some of these types of things actually only held in that particular region. And what we would do is there's things like media assets, things like movie metadata, these types of things, we would replicate that globally because that is generic data that is not covered by the data sovereignty, whereas data that you own, I'm Pete, then we need to keep that specifically inside Europe.
That's a great segue to things like S3. So where quite often we've talked about having lots of assets, media assets in S3. So how does S3 cope with being multi-region?
Yeah, so S3 has a mechanism which is called bucket replication. And you can set it up so that it will replicate between different regions from new objects or even modified objects. And you can set that, and that's a great way to replicate your different assets around the world. You might even be using this in your ingestion pipeline, for instance, where you need to get all of your data from, or all of your content from Europe or America down into Asia Pacific, for instance, where it's not actually produced. And so you can use the replication feature of S3 to do this. It also means that if you wanted to go multi-region and you didn't necessarily want to have all this extra infrastructure, you could just copy the data over as an S3 archive and then spin it up in the future if you needed to.
So Sean, that's pretty awesome. You can do so much by being multi-region, highly available, and keep your data in the right appropriate sovereign places. Just in closing, any kind of comments for anybody who is going to go global? Any kind of recommendations? I know I've covered a lot here. Anything really snappy to as main takeaways?
Yeah, I mean, we've talked about things like DNS. That becomes very critical when you go global. If you're still doing things like hand coding IPs or doing any of that kind of config management, it becomes quite tough. And then the other thing that we really need to emphasize is automation. You can't be hand rolling multiple regions worth of infrastructure. So definitely recommend doing some infrastructure as code or building it into your CI/CD pipeline so that you can roll this out to not just 1 or 2 regions, but maybe 10 or 12 regions.
Thanks, Sean, for showing us how to go global. Thank you, everyone, for joining us in episode 6 on how to build your video-on-demand platform and take it globally. We hope you've enjoyed it. Thanks for watching the last 6 episodes, and we both hope you've learned a lot about building your own video-on-demand platform, Sean.
Yeah, it's been heaps of fun, Pete. And we want you to try this at home. We've actually built out a sample of this architecture at amazon.to.byovod. So go out, try it. We'd love to hear your feedback.
And we always say there's never been a greater time to build, so go ahead and try this, build the next streaming platform, and go take over the world.